Good morning, students. Good morning, sir. Today we are going to explore something interesting, a new topic, right? So before we jump into a topic, let me start with a story. Okay, that will help what we are going to see today, right? Okay. So imagine you all are a postman, right? Have you imagined?
Yes, sir.
Now what you are?
Postman.
You are a postman. Okay. Now come and tell me, what is your role? If you are a postman, what is your role? Okay. We have to deliver the letters or post something to the concerned family or concerned house, right? So this would be our role if we are a postman. Now I have another question. Shall I ask you?
Yes, sir.
Okay. So while doing this job, what are the challenges that you are facing? Time management, difficulties, then energy level. Yes, you are right. So when we are doing this job, we are wasting our time and we are wasting our energy level. How it happened? How it happened? Because we don't know the exact route, right? Am I right, Avi?
Yes, sir.
Okay. If we don't know the exact route, what happened? We will visit the same house or the same street again and again. Okay? Repeatedly it will be happening. Okay, if it is happened, then definitely we will waste our energy level and our time, right? So, can we save that? Can we solve this issue? Is there any solution?
No, sir.
No. Who said no? Are you sure?
Yes, sir.
Okay. But I am saying here we can solve this issue by help of our today's concept, right? So that is what we are going to see today. So today we are going to discuss Euler's theorem. Euler's graph, not theorem, Euler's graph and Hamiltonian graph. Okay, let me explain what do you mean by Euler's graph and what do you mean by Hamiltonian graph. Okay, so Euler's graph is a path where we can cover all the edges without repeating, then we can return to the starting point. Okay, this is what you call Euler's graph. Hamiltonian graph is a graph. It is a path, right, where we can meet all the stations. It means vertices. All the stations without repeating. Then we can return to the starting station, right? Starting vertex. So this is what you mean by Hamiltonian graph. Okay, these two graphs is going to help us to sort out this issue. Okay, if you know the concept of Euler's graph and Hamiltonian graph, then you can save your energy level and you can save your time management, right? So I can explain this concept through an example. Just let me draw a diagram. So here we have, how many vertices we have? 5 vertices. We can name it the vertices. This is V1, V2, V3, V4 and V5. How many edges are having? So we can name the edges to E1, E2, E3, E4 and E5. So let me check whether this graph is following Euler's pattern or not. So for Euler's pattern, from where you start, okay? So you have to travel all the edges without repeating the edges. Now we are going to start from the starting point, right? So we have to cover all the edges by walking. At the end, we have to come to our starting point. This is what we call Euler's theorem. So we can start. We can come to this starting point. So this graph is exactly following Euler's pattern. This is called Euler's graph. Suppose if you draw this graph like this, here it is V6, then E6. Now whether this graph is following Euler's pattern or not? No. Why? Because we cannot travel all the edges without repeating. So you can start walking from here, here, here. If you go to this vertices, again you have to come to this vertices, right? So it is repeating, this edge is repeating. So this is not Euler's theorem, right? Let us come to Hamiltonian graph. Let me explain what you mean by Hamiltonian graph through this same example. So for Hamiltonian graph, we have to meet all the stations without repeating. Here, don't worry about the edges. Some edges you may cover and some edges you may not cover. It doesn't matter about here. Now, let us start working. This is a starting point. Then you can come to here, then come to here, then go to here, then go to here. Again, you have to come to here. here vertices are repeating. So this graph is not Hamiltonian. Am I right? For Hamilton, we should not repeat the vertices when we are making the station. Suppose if the same graph is like this, is it Hamilton graph? Yes. Now let me check. You can start from here, here, here. You can go to here, then go to here, then go to here. Okay, then go to here. So we have come to our starting point, right? So this graph is exactly following Hamilton pattern. Now here we have not covered this edges, so it doesn't matter. So edges, we don't worry about the edges. We have to take care of only the vertices. We should cover all the vertices without repeating. We have covered it. Okay, this is what we call Hamilton path. Okay, now these two graphs are helping us, okay, to find out which route is the shortest path and which station. If we choose which route, we can meet all the places in short time and we can save our energy. So these two graphs are helping us in that manner, right? Okay. Now I hope you all have got a clear idea about what do you mean by Euler's theorem and what do you mean by Hamilton theorem. So let me check whether have you got understanding? Okay. Let me check whether you have got a clear idea about this concept or not through an example. So we will be able to connect this concept in a real life example. Okay. So we are going to divide this student into two teams. Team A, Team B. Okay. Team A is going to draw a roadmap for our college by using this concept. So here your task is you need to meet A block, B block, C block, then library, then food court, then D block, then come to the main gate. Okay, so you have to meet all the stations, all the places. So what we will call if we meet all the places? Hamilton. So if we choose Hamilton graph, then we will have this. Here your task is you have to travel all the path inside the campus without repeating. So what graph we have to choose to come on, we will divide which team will finish this task first. Yeah. Who will come from your team? Yeah. Come on. So I expect if everyone participate in this video, then it will be a more active session. Yeah. So, yeah, you can draw it even more fast. Let us see which team will fall. Let us draw fast. I think boys team is going to win. They have drawn very well. They are mentioning all the vertices name exactly. So super Siddhartha. Very good job. This side girls team is also going to finish. Yes, super. Okay. Finish. Clap. Can you explain what have you drawn?
Main gate.
Yes.
From main gate we are coming to a block.
Yes.
A block. In A block we can see the B block and C block.
Okay.
Then we are going to I block, physiotherapy block.
Okay.
Food court, exam cell, D block.
Okay. So these are all the roads, right?
Yes.
All the edges are the roads. Here your task is you need to walk all the edges without repeating. This is the main gate. This is main gate. This is main gate. From here you are starting walking, right? You start walking. Now you are coming to here. What about the station? Physiotherapy. After physiotherapy, you go to food court. After food court, you go to what?
Exam cell.
Exam cell and D block. Then manual
Stationary.
Then you again return to the main gate. So what graph have you used to draw this? Euler's. Okay. Now you understand.
Yes, sir.
Have you understood? Okay. Thank you. Now let us come to this team. What is your task?
Here, main gate, A block, nursing, FC, and manual are all the respective vertices.
Okay.
Here we are traveling from main gate to A block, and A block to nursing, and nursing to FC, and FC to manual, and again from manual to we are traveling to
Super.
main gate.
Without repeating.
So it's become Hamilton.
So by using Hamiltonian graph concept, you have drawn this diagram. What is the benefit of this diagram?
Sir, without wasting the time, you can find the exact
Shortest path, right? So which means shortest path. So to find the shortest path, we can use the Eulerian graph and Hamilton graph, right? Okay, thank you so much. So we will meet you in the next video. Thank you.
Thank you, sir.